To be able to answer the question, how much should be baked each day to optimize expected outcome, we're going to have to produce a payoff table which would indicate, given any particular level of demand, how much should we actually produce. And given the fact that your demand is going to be 25, 50, 75 or 100, the options available to us are going to be, should we make 25, 50, 75 or 100. So to produce this payoff table, across the top we need to detail what our choice is, and in this case it's going to be how much do we choose to bake, and our choices are 25, 50, 75 or 100. And on the left hand side we then have demand, the chance element, and demand is going to be 25, 50, 75 or 100. And what we're going to have to do here is go through and try to work out all 16 possible outcomes depending on our choice and what happens with the corresponding demand. Now, if we think about what the question initially said, we make a loaf and it costs 50 cents, but we then get to sell it for $1.50, and therefore we're going to make $1 for every loaf of bread that we make and sell. So easy things first. If we were to bake 25 and demand was 25, then we would end up with 25 loaves, $1 each, so we'd make $25. And on a similar basis to where we've got the same amount baked as demanded, it's going to be $1 for each one. So that's going to be $50, $75 and $100. The key to this though, however, is if we choose to bake 25, it doesn't matter what demand is, you cannot sell more than you've actually baked. And as a result of that, you would get a profit of 25 no matter what if you were to bake 25. And then when you came to the next column, if you were to bake 50, as long as demand was 50 or above, you would continue to make 50. Similarly with 75, and then finally you can't have demand greater than 100, so that figure is already in there. For the rest of the figures that we've got to fill out, we just have to do a very quick calculation for each one. Now when we come to the next column, we have to be careful with this because we're actually producing more than we've got demand for. So what we can do with this is say, if demand is 25, we can sell 25 and we'll get in revenue of $1.50 for each one, but we've actually produced or baked 50, and each one of these costs us 50 cents. And therefore what we have with this then is 25 times 1.50 is 37.50. Take off 50 times 50 cents, 25. So we're left with a profit of $12.50. On a similar basis to the next column then, demand is still 25, so that's 25 times 150 is 37.50, but you now have costs of 75 times 50 cents, which is also 37.50, which means we will make no money. Then on the last one, demand is still 25, revenue is 150, so you've got your 37.50, but now we make 100 that cost 50 cents each, and in this instance we end up making a loss of $12.50. We can then do the same with the last three figures that we need here. If you were to bake 75 but demand was 50, you would get sales of 50 times 150, which is going to give you 75, and then you'll have variable costs of 75 times 50 cents, which will then give you a profit of 37.50. Moving across to the last column, if you had produced 100 and demand was 50, you would still sell 50 at 150, which is 75, but your variable costs are now going to be 100 times 50 cents, which is 50, and as a result of that we would end up making a profit of 25. The last figure then, if you made 100 and demand was 75, you would sell 75 at 150 each, which is 112.5, and then you make 100 of them at 50 cents each, which is a cost of 50, which will give you a profit of 62.50. What we then have on this table is all the possible outcomes depending on what you've baked and what demand is, but the question did specifically ask that what would be the best choice of bake every single day if you wanted to maximise your expected value. And therefore you need to bring in your probabilities for this, and if demand was 25, that has a probability of 0.2. If it's 50, you have a probability of 0.4. If it's 75, you've got a probability of 0.3. And if it's 100, you've got a probability of 0.1. So if you want to work out the expected value for each one of your options of what to bake, you need to go through and say this outcome times the probability plus that outcome times the probability, that outcome times the probability plus that outcome times the probability, and for the first column, no matter what, it turns out to be 25. But if we then move to the next column, you need to do $12.50 times 0.2, 50 times 0.4, 50 times 0.3, 50 times 0.1, add it all together and you will get 42.5. A similar approach to the next column will give you an expected value of 45, and for the last column you would get 36.25. Therefore, if you want to maximise your expected outcome, which could be 45, you would therefore have to bake 75 each day, and therefore the correct answer is C.